In this video, I'm going to show you how the SSIS Advanced ETL Automation process works. We are starting out in the Maestro database, and the table we're going to import into the data warehouse for this demo is TBL Contracts table. As you can see, this is a fairly large table with an extreme number of data columns. First, I want to show you where the heart of the ETL process resides. It's in a set of stored procedures in the master database. The primary SPROC is named USP SSIS Automation Script. And as you can see, there are currently 10 parameter values for the stored procedure. First is origin server. This is the server name where the origin data resides. The origin database, which is what it sounds like, it's the origin database, the schema name for the table that we want to import, the actual table name from the origin database, then the destination server, and as you can see in this demo, it's the same server as the origin server, the destination database, destination schema, destination table name. The schema name for the ETL, and you'll understand what that's for, and skip flags. I'll explain that later on. Now, when we execute the stored procedure, you'll notice the first thing the process does is gather a list of columns for the origin table. These columns are used, obviously, during the processing of the ETL process, or construction of objects, I should say. Then if you switch over to the Messages tab, you'll see some execution information that is being printed out. This is really only for troubleshooting purposes in case something unexpected happens during the process. Now, if we go back to the origin database, you will first notice that there are a couple of new tables which have been added. In this case, we have TBL Contracts Flags table, and this is basically only contains a few columns, which are the PKID identity column, the primary key for the origin table, last modified date, modified type ID, and CRM sync. The modified type ID column tells the ETL process which records have been updated since the last ETL run. The next thing you'll notice is there's a new trigger on the parent table. This trigger manages the data in the flags table structure, and it first detects the type of modification that's been made and updates the last modified date and modified type ID values. The valid values for the modified type ID column are 0 for no change, 1 for insert, 2 for update, and 3 for delete. These are important in the overall ETL structure, but they are what give the performance advantage of this processing type. The other table that's created in the origin database is the Update PKs table. And this table has a single column to hold the PKID values in order to reset the processed values to 0. Now let's look at the stored procedures that have been created by the ETL automation process. First is the keys reset SPROC. Then the select modified SPROC is next, and this one really does the heavy lifting in the origin database side as it returns both the origin table and the related flags table values for all records that have been updated since the last ETL run. Then we have the keys reset SPROC, which does exactly as the name suggests and resets all of the key values for records that were successfully processed into the data warehouse. That pretty much covers the origin database. So now let's look at the data warehouse side of things. In this case, the data warehouse is named EDW. And the first thing you'll notice is that we have a DIM contracts table as well as a DIM contracts keys table. Now currently the keys table only has the SKPKID value and the primary key of the parent table. Now let's delve into the actual SSIS process a bit. In the advanced ETL automation process, really the SSIS packages simply act as the orchestration piece for the process. All the package is really doing is passing data from one database to another and then calling the auto-generated store procedures, which actually do all the work. Since the process is really identical for almost every table, you can simply create a new package and then copy the SSIS steps from a previous package over to the new one. Then obviously you will want to rename your package to something more meaningful. I like to follow a naming convention that refers directly to the DIM table being processed. So I'll rename this one DIM contracts. Now all that's really left to do is to change the names of the objects being called by the packages to the new DIM table name. In our example, all I'm doing is changing the name from DIM client sharing to DIM contracts. As you can see, this is a pretty straightforward and simple process that's basically the same for every step. This makes it simple to create and manage the SSIS process and really easy to add new tables to the SSIS flow. Now, you'll notice that I have a couple of errors in the data flow task. The first one is related to a variable which holds a row count, which is used to check for updated records. If this value is 0, then the process simply stops for this part of the package process because there are no records to be updated in the data warehouse. Now, the next error is related to data mapping for the new columns. And this is because we're reusing columns from a different table set, thus the mapping is off. So what I like to do is simply delete the destination table object and add a new one. Then identify the staging table name in the target database. This automates the mapping of the columns based on the column name and just makes it a much simpler process to manage. You could simply rename the target table and then manually do the mapping, but I find this way to be much easier to manage and less error prone. Once you have created the new SSIS destination control, then you will need to select the SSIS staging table, which was also auto-generated by the SQL Automation process. This is the table that holds the data while it's being processed into the new DIM table structure. So we're going to drag down until we find the SSIS schema and the associated TBL contracts table. Then you simply connect it to the previous step and SSIS automates the mapping of the columns for you. So as you can see, when you have a lot of data columns, it's just simpler to create a new destination object and let SSIS handle the mapping for you. The next step in the package calls the new controller sprock, which was also generated for you by the SQL Automation process. This stored procedure controls the flow, which handles all of the CRUD for the updates on the data warehouse side. The next step truncates the update PKs table in the origin database to prepare for the newly updated PK values. As records are processed into the DIM table structure, the PK IDs are updated to 0, and any records which did not update for any reason are written to an error log, which will be discussed in a later video. The next data flow task transfers the updated PKID values from the data warehouse back over to the update PKs table on the origin database. It basically selects the PKID values which have a modified type ID of 0 and transfers them over to the correlating update PKs table in the origin database which you can really consider as a staging table for those updates back in the origin. And finally, the last step of the process executes the keys reset sprock, which updates all of the modified type ID values in the corresponding flags table back to 0. Now, as I said, any of the records which did not update for any reason don't get reset. So the next time the ETL runs, it'll try to process those records again, and hopefully, whatever was causing the problem before will be resolved. Now that we have finished updating all of the components in our SSIS package, we'll give it a test run for the first time to ensure all of the components were renamed correctly. We can switch over to the first data flow task to watch the number of records that are being processed. As you can see, the rows are being pushed over from the origin database table to the SSIS staging table in the data warehouse. And this particular table has just over 50,000 rows, so it takes a little bit of time to process, but it's not that bad. Since the rest of the process is calling highly tuned stored procedures, it all executes extremely fast compared to the initial data transfer, and the entire process completes in a matter of seconds. Now let's go back to our newly populated DIM contracts table and ensure that the data actually made it there correctly. We'll simply select the top 1,000 records, and it does appear that the data is there. So now let's look at our keys table to ensure the data also made it there correctly. Another select top 1,000, and there's the data. Now let's jump back to our origin database, and we will scroll down and find the TBL contracts flags table. We'll open that up, do a select top 1,000, and ensure that all of the modified type IDs have been reset to 0. It does appear that they have, so that looks good. And that completes the SSIS portion of the ETL process.